Hello and welcome. Thank you all for joining us for this Microsoft Reactor livestream event. Good morning, good evening, wherever you're coming from. We're happy to have you for this session. Today we will be having Yuanbo Xue, a software engineer from the Prague Microsoft team. The Fluent UI team at Microsoft Prague, joining us today. She will be covering Manage Accessibility with Virtualization, a part of our Fluent UI series that we've been running for the last week or so. We have the session today. We had two previous sessions, so if you happen to miss them, we do have those recordings up on our YouTube channel, which I will drop the link to our YouTube station into the chat. And we have another session coming up this Thursday. So if you're available and Fluent UI is of interest, definitely tune in for that last session of this 4-part series. The session will run for approximately 30 minutes with time for questions at the end. And then if this is your first time joining us, please note that for Teams Live, which is what this session is, there's a slight delay in the feed from the presenter to the audience. So we will be responding to questions, but it might not happen straight away. There's a little bit of lag time, so just keep that in mind. Don't wait till the very end to drop your questions into the chat if you have something that you've come here to ask specifically on this topic, or if questions come up as Yuanbo goes through her presentation, definitely drop them into the chat right then and there, just to make sure that we see everything before the session ends. Also to note, this session will also be recorded and uploaded to our YouTube channel, so if you're unable to stay for the entirety, or if you want to circle back and re-reference some of the material covered, it will be available on demand at a later date. And then finally, at the conclusion of this session, I will be sharing our feedback survey. We really appreciate any kind of commentary gauge to understand if the content we're providing is what our audience and community members are hoping to see. We use that for developing future topics and curating more content. So do please fill out the survey if you have the opportunity, and I'll drop the link to that and the event information into the chat as well. At this time, I would like to open the floor up to Yuanbo to start her session.
Hello, thank you, Rebecca, for the introduction. So I'm going to start the slides. Okay. So hi, everyone. Thank you for joining me. And today I want to talk about how do we manage the accessibility with virtualization in the Fluent UI in Microsoft. And a little bit introduction about me. My name is Yuanbo, and I'm from Microsoft in Prague. I work with Fluent UI, and Fluent UI is a component library that is based on React, and it is largely used across Microsoft Teams. So if you are joining this session from Teams Live, you may be seeing some of the components from the Fluent UI at this moment. And here I put some contact information about me. And if you like my session and would like to find out more, please send me a message. So since you're here today with me, you probably are attracted by the title of my session, Manage Accessibility with Virtualization. So both the accessibility and virtualization are interesting topics in the front-end development. And I'm happy that I have this opportunity to share my work on these two topics with you. In Fluent UI, we always take care of accessibility, and at the same time, it should perform very well by utilizing ideas like virtualization. So today, my approach is to show you a real-life problem that our team encountered in the Fluent UI. So here we have a tree component, which is what we have in the Fluent UI. And today we will try to make this tree component accessible and at the same time can also be virtualized. But before we dive into that, let's first take a look at what is a tree component and where it is used. So a tree component It is a hierarchical list, and any items in the hierarchy may have child items, and items with children can be expanded and collapsed. So for example, a file system navigator can display folders and folders within another folder. And this type of view could be provided by a tree component. And in Microsoft Teams, for example, the tree component can be used to render a participant list in a calling view. So here you could see participants in the call, and they are separated into two sections. And each section has a title and a list of participants within. So for example, for the first section, we have participants waiting in the lobby to be admitted by the host in the call. And also we have the second session, which are the people that are already presented in the meeting. And we can extract a hierarchical list from this view. So for example, for the first section, we have a title and also two participants. So we could extract it into an object that looks like this. So for the items object, you can see here we have the title for it for the first section, waiting in the lobby, and also a unique ID to identify this section. And there is also nested items within, which is our participants. We have title for each participant, which in this case, I simplify to just be the name, and also a unique ID to identify each participant. So after we extract this hierarchical list into items, we could pass the items into a React component named tree, and hopefully we will get a nice hierarchical view that can be expanded and collapsed. So this is actually, in fact, how we approach the tree items in the Fluent UI. So here I have a screen recording. If you go to aka.ms/fluent-ui, and this is the documentation side of the Fluent UI. So here on the left side, you could search for tree, and then click on it will show you the tree component. And there's many examples of how the tree component looks like and how they can be used in Fluent UI. And here, I just went down, I picked the first example. There's a toolbar and a button with try it on it. And clicking on this button could open an editor. So what I just did is I pasted the code that we've seen on the previous slides in this editor, like the same code. And then the Fluent UI doc site could render a tree view for me based on this code. So you can see we have waiting in the lobby, and then I can expand it and collapse it, and they form a tree view nicely. So yeah, as I mentioned, you could check out our documentation site by this link, aka.ms/fluent-ui, or just directly check our source code on the GitHub because it is an open source project. And our team in Fluent UI has 3 other sessions this month presented by my colleagues. They cover different aspects of web development, and I put the topics and the links there. So check them out if you're interested. You can find more details about them on the Reactor website. So back to our tree. Yeah, imagine to build such tree components by ourselves from scratch based on this items object that has a tree structure. So first we could we could create a tree using React. And first it would render a div container. And inside this div container, it could call like a tree item component to render each items in the tree. And then we could build this tree item component. So in the tree item component, we spread the item object, which is specifically for this tree item. So after we spread it, we get the ID, the title, and the children items of this tree item. So in the tree item component, we could render a div container with this unique ID. And inside this container, we render the title of this tree item. And then for each children items of this specific tree item, we could call the tree item component recursively to render them. So this is a pretty simple implementation, and this could give us a DOM structure that would look like this. Here we have a div container for the tree, a div container for the first section in lobby, and two nested div container for each participant in this section, me and someone else. So with this DOM structure and maybe some nice CSS styling, believe it or not, it could look like this. And of course, this is not the end of our story. Microsoft Teams is used in many different situations, especially during the pandemic. So for example, a college professor could be using Teams to deliver his or her class to the students from all over the world. And when there's 100 or even like 1,000 of students in one meeting, things could start to get really complicated. Let's think that, for example, if all participants are rendered in DOM, we may end up with a really huge DOM list. And this could lead to serious performance issues. Performance is crucial in calling application. When you speak, share your screen, mute or unmute yourself, you would expect these actions to take effect immediately. So for example, if I mute myself, I would want it to happen immediately and get some UI feedback of my action. And if the application is busy rendering, for example, the 50th participant in the meeting that I didn't even scroll to, and it couldn't change my unmute icon to mute, then I would be really confused. So this problem could be solved by an idea called virtualization. So for virtualization, some of you may have already be familiar with it. So I will just quickly go through the basics of what is virtualization. So virtualization is a technique for emulating a list with many items while only rendering a few of those items to make the viewport looks correct. So here, this orange box, imagine it as our viewport. So now only item 12 and 17 are visible inside this viewport. So for an end user, I don't need to care about items before 12 and after 17. So these items doesn't need to be rendered in DOM. And here I used color gray to show that they are not mounted. And when the user starts to scroll, for example, one item down, and now in this case, item 12 is scrolled out of the viewport and is now unmounted. And item 18 is scrolled inside the viewport and mounted. So the virtual list now looks like this. So the user can keep scroll, and items will keep getting mounted and unmounted. So when there are many items, virtualization could massively improve the memory consumption and also at the same time performance. And for our tree, of course, when there are many participants in a meeting, we could make it a virtualized tree. But now currently our tree renders a nested DOM structure as how we created just before. So in this case, it's not really good for virtualization because, for example, let's say if the in lobby item is scrolled out of the view and it is going to be unmounted. But because it is a nested DOM structure, all the children will also be unmounted. And this is not what we want, of course. So in order for our tree component to be virtualized, we will need to flatten the DOM structure to make it look something like this. So now the DOM structure is great for the virtualization. And with some CSS, we could make the flat list of DOM looks like a tree visually. And also the performance is not necessarily worse because the process of flattening the tree requires us to walk through all tree items only once. But at the same time, even though this might be visually good, but it is not enough for users that relies on screen readers. Because normally when a screen reader enters a DOM container with an area row of a tree or a group, it will try to figure out how many children elements are in this tree or in this group. and then announce this information to the screen reader user. And because of this, we have two problems. So the first problem is that the screen reader, it has no way to figure out this flat list is not a flat list, it's actually a tree. And the second problem, our tree is not virtualized. So some items within this tree is not mounted. When the user enters this tree container, the screen reader calculates the children elements within, and then announces this number to the user. But this number will be smaller than the actual items in the tree because of virtualization, and therefore it is not correct. And to solve this problem, we will need to set appropriate area attributes. So the screen reader could understand that this list of DOM is not just a list, it's a tree, and then correctly announce this information to the user. So after we added some accessibility attributes, the DOM structure should look like this. Here, the A11Y is short for accessibility because there's 11 letters between A and Y in the word accessibility. So let's go through this DOM structure of the enhanced tree. Now the tree div container has a row tree, and all the items inside this container has the row tree item. For the first item in lobby, it is the section title, so it is expandable, and we can see that it has an area attribute, area expanded, and it is true, which will make the screen reader announce that this item now it is expanded, and also it is expandable. And the second attribute, the area level. So area level tells that this is the first level of the tree item. So for the second and third item, because they are one level nested underneath the first item, so their area level value is 2. And also area set size. So it shows that there is one item in the set for this in lobby item. Because for the first level of tree, there's only one item in lobby, so the area set size value is 1. And for the second level of the tree, there are 2 items. So the area set size for the second and third items is 2. And the area post inside, this attribute means position in a set. So it tells that the in lobby item is the first item in the set. And also the participant 0, which is me, is the first item in the set, which is the second nested level of the tree. And of course, the participant 1 will be have the value 2 because it is the second item in the set. So through setting all these accessibility attributes, the user could rely on the screen readers to understand the UI. And please note that here, we know the value of all these area attributes because we have flattened the tree once. And flattening the tree gives us opportunity to figure out the proper area value for each tree item because we walk through all items in the tree for once. So this is still not the end of the story for the accessibility and virtualization. But if you have any questions for this previous part, please feel free to drop them in the chat. And of course, the accessibility requires us to handle also the keyboard navigation. It is a really important part and is heavily used by screen reader users. Previously, I mentioned that the file system navigator is a tree. So I would like to show you some typical keyboard navigation for tree on a file system navigator on Windows. So here, for the start, I have arrow key up and down. This could make me navigate up and down the tree. So yeah, here I have a screen recording of a file system navigator in a Windows computer, and I have here like 3 items. And when I do arrow key down, it will navigate down to the bottom for me, and then arrow key up will go back to the first item. So this is the first type of keyboard navigation. And the second type, this is less well known. You can actually use arrow key right to expand an expandable item. And after you expand it, the arrow key right again will focus to the first child of this expanded list. So here, my focus is now on quick access. And if I do arrow key right once, it expanded. And then the arrow key right again, it focuses on the first child of all its children items. So the third type of keyboard navigation is arrow key left, is similar like arrow right, but instead of expand and navigate to the first child, arrow left once will navigate to the parent item, and arrow key left again will collapse this collapsible parent item. So yeah, still the same example. Now I am at the first child of the quick access. And now if I do arrow key left once, it focuses on the parent item. And the arrow key left again collapse this item for me. So there are actually a lot more ways to navigate a tree other than the ones that I've just showed. And you can find all of them on Area's webpage. And I put a screenshot of all the keyboard navigation listed on this page. We don't need to go through them. It's just there to make a point that an accessible tree component should support many different types of keyboard navigations. And now let's take a look at how to do this in our virtualized tree. So far, we've been talking about a list of participants in the call, but I couldn't come up with a big list of participants' names. So I used a virtual list of fruits instead. And here we have a big list. The first item is fruits. And the nested items underneath the fruits are all different types of fruit. So now let's assume that we navigate to the kiwi item, and kiwi is actually in the viewport, so it gains focus. So now when the focus is on the item kiwi and we do an arrow key left, then that means the parent item of the kiwi should gain focus. And this parent item is fruits. But the problem now is that fruits is not mounted, it's grayed out, because it is outside the viewport. So because of the virtualization, it's not mounted and we cannot put a focus on it. So this was actually the problem we were facing in Fluent UI. After we flattened the tree, we virtualized it, the keyboard navigation suddenly stops working. So let's take a step back of how to deal with it. We flattened the tree, and during this process, we walk through the tree. And because of that, we know the parent of kiwi is fruit already. We did the flattening of the tree for virtualization. So we just need to find a way to focus on fruits. So we navigate from kiwi to fruits and then focus to the fruits item. We can separate this process into 3 steps. First step, we want to scroll the fruits into the viewport so it's mounted. And the second step, we wait for fruits item to be mounted. And then the third step, we can put focus on this fruits item. So for us in the Fluent UI, the first step is relatively easy because we use React window to implement virtualization. A React window is a popular open source library for virtualization. It's written by the same author of React Virtualized, Brian Wang. And the React window has everything that we need, and it's smaller and faster than React Virtualized. So we chose it in Fluent UI. And React window has an API called scroll to item. So this can be used to scroll to any index inside a virtual list. So again, because we flatten the tree and we know the index of the item fruits. So we just need to call this API to scroll there. This scroll is actually an effect. It does not happen synchronously. So actually in the React window, the scroll to item will call its set state. and scroll will happen on the next render. So, and then for the next steps, mount and focus on the tree item. So initially, I implemented in this way. So we know that the ID needs to be focused. So we could pass this ID to tree item components through a context created in the tree component. And in the tree item component, we consume this context and get this toFocus ID. Here I used a callback ref in the tree item. The callback ref will be fired when a React component is mounted, unmounted, or has DOM change. So when this tree item is mounted, after scroll, the callback ref will be executed. And inside this callback ref, we compare the ID of this tree item with this toFocus ID. And if it is the same ID, we could put a focus on it. So at this point, I thought, great, the work is done. The tree is virtualized and accessible. But you probably already see some problem with this approach. So the first problem is if the item fruits is already in the viewport, meaning that it's already mounted, the callback ref will not be fired. So it will not be focused. And the second problem is that every time when I change focus by pressing an arrow key, all the tree items will get updated. This is because the toFocus ID is in a context. And once it is changed, the context will be updated. And when the context is updated, all the components consuming this context will get re-rendered by React as well. So this is obviously not what we wanted. And instead of passing the toFocus ID in the context, we have a new idea in Fluent UI. So here in the tree item component, you can see that instead of the toFocus ID in the context, we created a function called register item ref. And this register item ref is passed through context and is called in the similar way in the callback ref. And in the tree component, I tried to simplify the code, so I apologize if there's a lot of source code. So let's go from the top. So in the tree component, we created an object called nodes. And the nodes is a collection. The key of this collection is each item inside the tree. And the value is the reference to the DOM of that item. So when a tree item gets mounted or unmounted or has DOM change, the callback ref will be fired and it will execute register item ref. And then this nodes object will be updated in the register item ref. So it will be updated with the new reference to the tree item. So that's why we call this function register item ref. And the logic of comparing the tree item's ID with the ID to be focused is removed out of the tree item and moved inside this register item ref. And when an arrow key is pressed, for example, and a new item needs to be focused, there will be an event handler, and this event handler could call a new function called focus item by ID. So inside this function, if we check that this tree item is already mounted, meaning that we can find its reference in nodes, then we just put focus on it. And if it's not mounted, we just need to set toFocus ID. And then later, when this item does get mounted, the callback ref will be fired, and the register item ref will be executed, and then this item will gain focus. So now you can see that in the dependency array of these two functions, register item ref and focus item by ID, there's only one dependency, which is the toFocus ID. So these functions will be stable unless the toFocus ID has changed. And in this case, the nodes object is not in the dependency array because it is a ref, so it is always stable. So now all we need to do is to make this toFocus ID stable. And then the tree context will contain only stable functions which will not change on users' interaction. And this can be done simply by using a ref to remember this toFocus ID. So here now these two functions are stable, and the context value we pass down from tree to tree item contains only stable functions, and this will not cause us additional rendering. So now we have a tree component that can be virtualized and also has a great accessibility support at the same time. Let's recap a little bit. Relax after seeing so much source code. So for the start, feel free to drop any questions in the chat and I will take care of them at the end of the session. So far, in order to create a tree that is accessible and can also be virtualized, we took two big steps. The step one, we flattened the tree. It makes the virtualization possible, and it provides us some data to be assigned to the area attribute of each tree item. And the second step, we created a stable context to handle the keyboard navigation, to reduce the number of re-render as less as possible. So within Fluent UI, we put everything into reusable hooks. We have a use tree hook for the classic tree component that handles keyboard navigation, and also a use virtual tree hook that handles accessibility when the tree is virtualized. So I put also links to the source code because we are open source project. You can check the source code, and any sort of feedback is very welcome. So that's the end of the session for me today. Thank you everyone for joining me, and I hope this session helps you in any way, and it helps raise some awareness in accessibility. So I guess I can give it back to Rebecca.
Hello. Thank you so much. That was wonderful. We had a couple of questions in the chat, but I believe one of them was answered early on. They were asking what you had been using, and correct me if I'm wrong, but it was North Star, correct?
Yes.
Okay,
yes.
Great. So that was one of the questions early out. And then someone also had requested, if possible, to publish some of the references that you have highlighted in your presentation. And if you want, while I'm running through my last couple of slides, if you want to drop any of those links that you had in your content into the chat, I'm sure people would appreciate it. So the open source and things like that might be helpful to the audience. So I'm just going to share my screen. Just give me 1 second to pull it up. Just bear with me momentarily. Here we go. There we go. So if you want, you can leave your camera on or turn. Okay, perfect. Thank you. So no worries. Yeah, you can turn it off just because I'm going to be chatting through. So unless you want to hang out there, you're more than welcome. So yeah, my slide is for the upcoming and currently final. I mean, we'd love to have the Fluent UI team back again for additional sessions in the future. But for now, this was a 4-part series that covered various aspects of Fluent UI. The final session is this coming Thursday for US and much of the world's time zone. If you're joining us from another place in the world, it might be the following day, but just, or the day before, who knows, depending on where you're located. But I did share in the chat a link to the calendar. I also dropped the previous session recordings into the chat as well, part of our YouTube playlist. But yeah, if you are available and free and Fluent UI is something that interests you, I strongly urge you to check out the next session and also revisit the past couple if you were unavailable at that time. Our program, the Reactor, which is part of Microsoft, if you're not familiar, has 12 international physical locations. And we were doing in-person sessions. Now we're currently virtual. Eventually, we will most likely have a hybrid setup as we return to in-office capabilities. So if you happen to live nearby, definitely keep an eye on those calendars for in-person as the situation around the world progresses. But also because we right now are on a virtual platform, our sessions are available to everyone and anyone. So do check out the various locations because depending on your personal schedule, maybe for one day, a session that's being held in Sydney, Australia might work for you. And then another day, something in New York might work for you. So it's good to, sign up and be a part of the community. Check out our Microsoft Meetup pages. Also, for more direct and maybe a bit more easy navigation for multiple time zones, you might want to visit the MicrosoftReactor.com main website and choose locations based on what works for you. We also have a newsletter that we recently rolled out. So based on your time zone, again, you can select your region and we'll send you once a month an email with everything coming up that's already on the calendar for the following month. So aka.ms/reactor email sign up, really easy, one big email, not multiple SAM or anything like that. So it might be helpful for you to keep track of these sessions that way. So definitely check that out. And again, our YouTube channel has lots of content, so many things out there. So definitely feel free to tune in there as well. We run a lot of live sessions through YouTube, but we have all of our session recordings available, free content, lots of topics. Definitely take advantage. And then previously I dropped into the chat our survey link. Again, if you don't mind, if you have the time, we do appreciate it. Just follow that link and then enter event code 12997 to give us your feedback on this session, and we use that for planning future content. So now I will circle back to Yuanbo. There is, I think, at least one question came in. Oh, okay, so you answered it in the chat. They had asked what virtualization libraries are compatible with Fluent UI Tree component, and you wrote, for now, we just React window. Yeah, so if you want to speak about that at all, you're more than welcome to pop back on now and do so. And then someone also just made a point to comment about there's a lot going on under the tree.
Thank you, Rebecca. So I just wanted to elaborate a little bit more on this question on what virtualization libraries are compatible. So our idea is we implement this reusable hook, use virtual tree, and this use virtual tree is focused on React window. But we hope like this idea of use virtual tree can easily be reused by anyone who are using like their own component library. For example, it doesn't necessarily have to be Fluent. So they could take care of the accessibility in the similar way like we do. The tree component itself in Fluent UI, we have an API that allows this tree component to support any sort of virtualized library. And it's, let me check. Yeah, the props name is rendered items. So the tree component gives you a flat list of items that it rendered, and you can just manipulate it to be however you want. That's how we made it compatible with any sort of virtualization library, but it doesn't have the accessibility baked in. You will have to take care of the accessibility by yourself. So it's a trade-off. We took care of accessibility, especially for React window, but for other type of virtualization, it's possible, but the accessibility is not there.
Awesome. Well, thank you so much again. It looks like that was the last of the questions for now. I'm sure people will ruminate and think of things in the future. If you do have questions later on, if you rewatch the session and something comes up, you can feel free to reach out to myself or the Fluent UI team directly. A lot of them can be found on LinkedIn or Twitter. So do feel free to, follow up, learn more, ask more questions. They're always welcome. At this time, though, I think we will wrap it up. We've gone over by a little bit here, and it seems like we've covered the questions asked in the chat. So once again, Yuanbo, thank you so much. This was great. We really appreciate it. And again, to everyone tuning in, if you're interested, this coming Thursday, we have the last session for this current series. Someone asked if you're on Twitter. Yuan, sorry. Last question. If you want to share your information, you can drop that into the chat. But yes, at this time, we will conclude this session. Until next time. And again, this session will be recorded and available in the next couple of days on our YouTube channel. So just, I dropped the link in the chat, but if you didn't find it there, you can always just search Microsoft React or YouTube and it will be there.